Moving forward with our quadrilaterals, we're going to get more specific. So, just a little bit quick review. We have our quadrilaterals. That finger's up there. There we go. Quadrilaterals, four-sided figures, interior angle sum of 360. Then our quadrilaterals became parallelograms. Parallelograms come with two sets of parallel sides, and then the properties that followed. If it's a parallelogram, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and our diagonals bisect each other. Parallelograms are still quadrilaterals, so they still have an interior angle sum of 360, and they are still made of four sides. So what we're doing today is we're actually going to get a little bit more specific about our parallelograms. My parallelograms get more specific when we call them rectangles. Or our parallelogram becomes a rhombus. What makes it a rectangle and what makes it a rhombus? That's what we're going to talk about today. So, for a parallelogram to become a rectangle, it becomes a rectangle when it has four right angles. So our parallelogram now has four right angles. We'll still have opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and our diagonals still bisect each other. So everything that's true about a parallelogram is still true about a rectangle. But now that it's a rectangle, it has a new property. The new property for rectangles is our diagonals are congruent. So what that means, if I were to come in and draw my diagonals here, when they bisect each other, these four segments are now all the same length. Okay? Because the diagonals are congruent, those diagonals are bisected into four congruent segments. Yeah? Okay, rectangles. So I've got an example here. We know it's a rectangle. I'm giving you the fact that it is a parallelogram. Then I define it as a rectangle by putting in the one right angle. Opposites are congruent, so that would be 90. These are consecutive, so that would have to be 90. It is a rectangle. So if AE is 15, what does EC equal? Well, because it's a parallelogram, the diagonals bisect each other. That's going to be 15. Then I want to know what BD equals. Well, since my parallelogram is a rectangle, the diagonals are congruent, so BD is going to equal 30. Rectangles. Pretty straightforward, yeah? Cool. Okay, now we're going to look at the rhombus. When you pluralize a rhombus, it becomes rhombi. So if you got two, you got rhombi. All right. It becomes a rhombus. Instead of four congruent angles, we have four congruent sides. So our rhombus will look something like this. It is a parallelogram, so we still have the parallel sides, congruent opposite angles, all that. But now we have four congruent sides, making it a rhombus. Okay, with the rhombus, it still has all of the properties of a parallelogram and a quadrilateral, but now it has a couple of its own. First one, now that we have a rhombus, our diagonals are perpendicular. If you remember, to be perpendicular, it means they intersect at 90 degrees. So if we come in with our diagonals, we're going to have four right angles in the middle of that rhombus. Our diagonals are perpendicular. Another cool feature, our diagonals, they're going to go ahead and bisect the opposite angles. So what I mean by that is this angle is congruent to this angle. This angle congruent to that angle. They're cut in half. Bisect means cut in half. Okay? So I've got an example problem here for a rhombus. I want to know what the side length of the rhombus is. Well, since we know that our diagonals are perpendicular, we could zoom in and just look at this right triangle right here. And if we're solving for the hypotenuse of that right triangle, we're going to go ahead and use the Pythagorean theorem. Reminder, the Pythagorean theorem is a squared plus b squared equals c squared, where c is always the hypotenuse. So this will be 3 squared plus 4 squared equals c squared. 9 plus 16, so 25 equals c squared. Go ahead and square root that. That's plus or minus 5, but because we're talking about a distance, we know that that is just going to equal 5. Okay? Pythagorean theorem to solve for that, because it's a right triangle, because our diagonals are perpendicular. Okay, so our parallelograms got more specific. They became rectangles based on the 4 congruent angles. They became a rhombus. Ooh, I got tongue-tied there. It became a rhombus when it had 4 congruent sides. Well, what about our shape, the square? A square has 4 right angles and it has 4 congruent sides. So a square is going to take all of the properties of the rhombus and all of the properties of a rectangle. And since they're all parallelograms, all of the properties for our parallelograms, rectangles, and rhombi are all going to apply to squares. Squares are a very simple shape, but since they have all of these properties, they're actually quite complex. So, last problem that I have up here for this is we've got a square. I've got the diagonals drawn. I want to know what the measure of angle BAC is, this angle right here. Well, because a square is a rhombus, we're going to use this property that our diagonals bisect the opposite angles. This angle was originally 90 degrees, so I'm just going to bisect it, which means I'm going to divide it into 2, cut it in half, and that's going to be a 45-degree angle. Okay? Nifty. Okay? Lots of information there, but if we can keep track of it, pretty straightforward. If you got questions, let me know.